Hi, and welcome back to another STEAM Tastic Wednesday activity. And today we're back in Metaspace 511, which is just really exciting to be back here. And we're excited to be back in the library to be doing some of our fun activities. So I hope you have fun with this one. And today we're going to be doing a sort of science experiment about how ice, really just how heat is transferred through either an insulated area or a non-insulated area. So first what you're going to need are just some ice cubes. Doesn't really matter what kind, just make sure you have two that are about the same size, two of the exact same lids or containers with sealing lids, it can be like a plastic cup or a small paper cup, or we're using some bags, just something that is going to hold the water in when the ice melts. And then something to insulate one of the containers. So you can use things like bubble wrap, cotton, you can use crumbled up paper. If you have actual foam board, that's even better. Something that can go around one of our bags to hold in some of that, or insulate the ice cube. So what we're gonna do to start out is open up our containers. And so one of them is going to have just a plain old ice cube, and then the other one is going to have the ice cube insulated in something. So what we're going to do is take our ice cubes and put them into our bags like this. Doesn't really matter how much air is in them. And like I said, it can be a cup as well, just anything that'll keep in that water. So your insulated material doesn't get all wet. And so what we're going to do is put them both into their containers, and one of them is going to be insulated. I'm going to use the cotton today, so I'm just going to use this cotton as, I keep saying insulator. What an insulator is just something that either keeps out the heat or keeps in the cold, or like maybe in the winter when you are cold in your house, or when it's cold outside and you have the heater going, insulation in your house is what keeps in all of that heat for you. So what this is doing, this cotton is doing, is really just insulating this ice, so all the heat from the outside doesn't get in as easily, and the cold from the inside doesn't escape as easily. And so I put the lids on both of them, and I want them to be sealed tight. And so what you want to do is keep both of these containers in a similar area, like right on this table, or if you want to put them outside, that'll make it go faster. You can kind of see the process quicker. Where it's you're going to watch and see what happens with the ice. So we're using a sort of scientific method of having what we call a control, which is just an ice cube in its normal state, just sitting in a container, and then our actual experiment. And so we know what's going to happen in this one. If we let it sit out in the sun, the ice is just going to melt. But your goal is to see what's going to happen with the other ice cube, and see maybe like, does it melt faster, does it melt slower, and then compare the two and see why this one was different than this one. Once you have this done, wait about 15 minutes or so. Just give it enough time where this ice cube is going to melt fully, and then you can compare to this one and see, did it melt all the way? Did it not melt all the way? Is it still full? But what I want you guys to do is to try some different insulating materials. Like if you used cotton balls first, try maybe bubble wrap or crunched up paper, or like the insulating foam like I talked about. Or think about maybe giving it more space. So what if you had a container like this and then a container that's huge and you didn't do any insulation? See what differences come with that, or in two smaller containers and do the insulation and non-insulation, and just see what this, like giving it more space, can do for it. and just think about the different things that insulate the heat and keep the heat in, or keep the heat out. So insulation really just takes control of heat transfer, which is really just the transfer from a high level of heat to a low level of heat, or high concentration of heat to low concentration of heat. And so since our ice cube is really low concentration of heat, there's not a whole lot of heat, and there's more heat around it, the heat wants to kind of go in, so then the ice can lose its heat and then everything can be equal. So that's what happens when an ice cube melts, is it loses its heat because the rest of its environment is warmer than it is. So with insulation, heat really can't get in because heat is transferred in 3 different ways, which is conduction, convection, and radiation. Conduction is when you touch it. So like if I had a hot piece of iron or something and put it onto this, it would melt it, and really it would melt the container and everything around it because the heat is directly coming from that, and that's conduction. Convection is kind of from around it. So if I put this over a hot stove top and just kind of let it sit there, the heat would come up, and while it's not touching, the heat, if you've ever put your hand kind of over a hot stove, you can feel that heat kind of coming off of that. And that's some convection, and it's also what's called radiation, which is the other type of heat transfer, which is just, it's through this type of wave, and all heat is waves, but radiation is really small waves. And so like with a microwave, how it shoots out what are called microwaves, and that's radiation, and that heats up. And it's the same thing from the sun. The sun shoots UV rays onto us, and that's what feels warm to us, is that radiation coming from the sun. It's not bad radiation. Well, in large amounts it is, but UV is what kind of gives us heat. And so this insulation is what kind of blocks those heat waves, whether it be radiation, convection, conduction. It keeps that stuff out a bit more, and it's not perfect, like there's holes, so it's always something is going to escape at some point. But the insulation really helps protect from those heat waves and stop the heat waves from the ice from escaping. Thanks for watching, and I'll see you guys next week.